In this section, we'll be solving systems of linear equations. So what we want to do is we want to determine whether one of the following ordered pairs is a solution to the following system of equations. So we're given the ordered pairs 1, minus 3, 0, 1, and 2, minus 2. And we want to know if one of these ordered pairs is the solution to the following system of equations. We have y equals 3x minus 8, and we're given y equals x minus 4. Okay, so when we talk about a system of equations, we're dealing with a set of equations, 2 or more, in this case 2, graphed on the same coordinate axis. While a solution to a single equation is any point that lies on that line for that equation, a solution to a system of equations is any point that lies on every line of the set of equations. In particular, it's where the lines of the equations intersect. So the algebraic solution is an ordered pair that solves both equations. And we can check the solution by plugging in the ordered pair into the system of equations. And if the ordered pair solves both equations, then that means it's the solution to the system of equations. So let's go ahead and plug in each ordered pair one at a time into both equations. So let's try the first one, 1 and minus 3. All right, and let's plug it into one equation at a time. We have this one first. We have minus 3 equals 3 times 1 minus 8. Let's go ahead and solve that. So we have minus 3 equals 3 minus 8, which gives us minus 3 equals minus 5. Now this is not a valid statement, which means the point 1 minus 3 not only doesn't lie on this line, but it doesn't satisfy the system of equations. So we don't even need to try it in the second equation because it has to satisfy both of them to be a solution to the system. All right, so let's try the next one. That one doesn't work, so we have 0, 1 for the next one. 0, 1, let's go ahead and plug it into the first equation. So we have 1 for y equals 3 times x, which is 0, minus 8. 3 times 0 is 0. This isn't going to work out because we have 1 equals minus 8, and that's not a true statement. So we don't even need to try it in the second equation. It has to satisfy both of them. So 0, 1 does not work. It's not a solution to the system of equations. Let's try the third one. We have 2 and minus 2. Let's go ahead and plug it in one at a time. So y equals minus 2 equals 3 times x, which is 2, minus 8. Gives us minus 2 equals 3 times 2 is 6, minus 8. And we have minus 2 equals 6 plus a negative 8 is minus 2. That checks out. Minus 2 equals minus 2. That's a true statement, which means the point 2 minus 2 is a point that lies somewhere on this line. Now we need to plug this into the second equation. We're not done yet because for it to be a solution to the system, it needs to satisfy the second equation, which means it needs to lie on the second line as well. If it lies on both lines, then that means this is the point where the two lines intersect. All right, so let's go ahead and try it in the second one. So we have y equals minus 2. So minus 2 equals x, which is 2, minus 4. We're just plugging it into the second equation. This gives us minus 2 equals 2 plus a negative 4 is negative 2. That actually works out again. So we know that the point 2 minus 2 is indeed a solution to the system of equations. This is the point where the two lines intersect. All right, so that should make a little sense for us. We've been graphing equations long enough. Now we're just determining where the solution of equations for a system of equations. That's the intersection. So let's go ahead and look at the next one. We're given the ordered pairs for the points 1 minus 2, 2 and 2, and 4, 2. And we're also given the linear equations y equals 2x minus 2 and y equals 4x minus 2. So this is our system of equations, and we want to see if one of these ordered pairs is the solution to the system of equations. Or also think about it, which of these ordered pairs represents the point where these two lines intersect. And for that to happen, this particular point needs to satisfy both equations. So let's try one at a time. We have 1 minus 2 Let's plug it into the first equation. So we have minus 2 in for y. So we equals 2 times x, which is 1, minus 2. Minus 2 equals 2 times 1 is 2, minus 2. And we have minus 2 equals 0. That is not a true statement. So 1 and minus 2 is not the point where these two lines intersect. It's not a solution to the equation. So let's try the next one. We have 2, 2. Let's go ahead and plug it into the first equation. So y equals 2. So 2 equals 2 times x is 2 minus 2. There's an awful lot of 2's going on here for some reason. So we have 2 equals 2 times 2 is 4 minus 2. So we have 2 equals 4 minus 2, which is 2. 2 equals 2. That's a solid statement. So this is a point lying on this line. Now we need to see if it's a point lying on this line as well for it to be an intersection. So let's plug in 2, 2 for our second equation. So we have 2 equals 4 times x, which is 2, minus 6. That gives us 2 equals 4 times 2 is 8, minus 6. And 2 equals 8 minus 6, which is 2. That's another true statement. So that means the point 2, 2 is the point where these two lines intersect, which also means that 2, 2 is indeed the solution to the system of equations. All right, let's go ahead and do one more just for a little practice. Let's say we're given the origin. We're also given the point 0, 1 and the point 1, 0. Awful lot of zeros here, so this will make life easier. We're given the system of equations y equals 2x minus 2 and y equals 3x minus 3. All right. We can actually eyeball this one by zeroing out our variables we can just cancel out the origin, because if we plug in 0, 0, we can see that this doesn't work. We'd get 0 here and 0 here. 0 doesn't equal a minus 2, so we can cancel that one right off the bat. So let's try the next one. We have 0, 1. 0, 1, we plug it into the first equation, so we have 1 equals 2 times x, which is 0, minus 2. This gives us 1 equals a minus 2, and that's a false statement, so that indeed won't work either. So let's take a look at the third point. So we have 1, 0. Let's plug it into the first equation, 0 in for y, so 0 equals 2 times x, which is 1, minus 2. We have 0 equals 2 minus 2, and that'll give us a true statement. 0 does equal 0. We're not done yet because this is a system of equation, so we need to check it for the second one as well. So we have y equals 0. 0 equals 3 times x, which is 1, minus 3, which equals 0 equals 3 minus 3, and that indeed will give us another true statement of 0 equals 0, which means the point 1, 0 is the point where these two lines intersect and is indeed a solution to the system of equations. All right, so we're solving linear systems by checking some ordered pairs. In the next section, we'll be solving systems of equations by graphing. Now you'll see there that we only get an approximation of where the two lines intersect, but it is indeed helpful, especially in real-world applications, which gives us a visual representation of what a linear system of equations looks like. So I'll see you in the next video.